31, region in the first quadrant bounded by this and the x-axis. If the area of the region R is 18, then the value of k is. So the deal is I got to find out an integral of negative 4x squared plus 2 times 3x. And then I have to figure out what the limits of integration are, and hopefully that equals 18. This is calculator active. So I have to do this a couple of times. So my second integral is going to be from I don't know to I don't know of negative 4x squared plus 2, but this time times 6 times x. And that's supposed to equal 18 each time. And we're going to follow this process. We're going to keep doing that until we figure out which one of these actually adds up to equal 18. So it's going to be 2 times 9, x equals 18. And here's what this looks like in the calculator. So in my y equals node, notice, I've entered each of these graphs. And I'm going to figure out where they intercept the x-axis to get my limits of integration for each of these. And notice that's 2 times 3 is 6. 2 times 6 is 12. And I just left that one as 2 times 9. So you can see that you can enter it into the calculator like that. And the last one was 18. The multiple choice select was 18. So I put the 18 into my calculator. Now I'm going to graph all 4 of them. Here's the first one. That's this graph. There's the second one. Notice they're all concave down, negative 4x squared. There's the third one. And the fourth one is a whopper. It's way off the screen. So I'm going to investigate the first graph. Second calc, I'm going to find a 0. And let's see here. Where's my fluffapuff? I'm pretty sure it goes from 0 to 0. So my left bound is going to be, see it? My left bound is going to enter, and yeah, it's going to be 0, 0. So that's going to be 0 on the bottom. Then I'm going to hit second calc, and I'm going to find the other 0. When that first graph, it's still on y1, still looking at y1. So I bring my fluff puff over, enter, and that's going to be 1.5. So the area under the curve is going to be from 0 to 1.5. Now I might as well, while I'm here, get the other graphs. So second calc, 0. Notice they all go through 0, 0. So I'm okay with that. They're all going to be, the lower limit is 0. The lower limit is 0. I need to figure out what the upper limit is. In this case, the upper limit was 1.5. So let me up arrow to, whoops, second graph. Left bound, enter, right bound, enter, and that one's at 3. So it's going to be from 0 to 3 for that graph. Second calc, 0. I want to go to my third graph, so I up arrow toggle to the third graph. Left bound, enter, right bound, enter. I don't want to guess. I hit enter, and that's going to be 4.5. So from 0 to 4.5. And my third graph, I might as well get it while I'm here. It's going to be f of x. I'm just going to put that from 0 to I don't know yet. So I'm going to figure that one out. Second calc, 0. And all I'm trying to do is find my limits of integration. There it is. Enter, cross it, enter, 9. So now I'm going to figure out the area for each of these. Let's see. Second quick. I already math 9'd it. So my first one's going to be from 0 to 1.5 of alpha y equals my first graph with respect to x. It does not equal 18. So it cannot be my first choice. Math 9 from 0 to 3 of the second graph. Alpha calc, second graph, dx. Bingo, that is my answer. This one worked from 0 to 3. Choice B. So they want me to find h prime of 1.35. And notice there's no h over here on the graph, on the table. So I'm going to generate the derivative. So h prime of x equals f prime of g of x times the derivative of the guts, which is going to give me g prime of x. Evaluated at 1.35. So h prime of 1.35 means I throw 1.35 in for each of these. So that's going to be f prime of g of 1.35 times g prime of 1.35. And I'm sure we can find these in the table. Let's see. G prime of 1.35, G prime, no G prime of 1.35. That's a tough one. But G of 1.35, G of 1.35 is 2.7. So I can carry on. That's going to give me f prime of 2.7 because G of 1.35 equals 2.7 times that. Well, I think what I'm going to do for this is just the average rate of change. The slope at this is not this. It's going to be the average rate of change. So I'm going to multiply this times 1.4, I'm sorry, 2.9 minus 2.5 over 1.4 minus 1.3. And that'll give me the slope. That's equidistant between those. It's the same as the derivative. Now, f prime of 2.7 is 3.97 times this monstrosity. 2.9 minus 2.5, I believe, is 0.4 over 0.1. This one here is an FTC Part 2, Fundamental Theorem of Calculus Part 2. So if I have an integral from 2 to 7 of the derivative of something, that's going to equal the antiderivative, f of 7 minus f of 2. And I have a function that I can throw in here, and I know that f of 2 equals 8. I need to do is find out what this value. It's going to be from 2 to 7. Now we have to enter this function in, cosine of 1 minus x squared. So I'm going to alpha y equals to get my fraction going. Whoops. Let's see what happened there. Alpha y equals fraction cosine of 1 minus x squared. Close parentheses, down arrow, x squared. Plus square root x. Pretty complicated, not capable of doing it by hand. You'd have to be pretty good at finding the antiderivative for this one. And then just enter that. It's even taking my calculator a while. But that's going to be my value over here. So that's going to be negative 0.0182. So this value over here equals negative 0.0182. And I'm going to cut it off there. And then I'm going to add 8 to both sides. I'm going to add 8 to both sides. So I add 8 here, and I add 8 to that monster, and it's just going to be my calculator, plus 8. And that gives me 7.982. Choice C. Number 34 wants to find out where this function, in the interval from 0 to 5, is not differentiable. So that means the graph of this function. And recall, it says absolute value. That's the key factor here. So you have to hit, in order to graph it, you would have to hit alpha window to get the absolute value started. And then in order to get it to be sine squared, which is kind of difficult, notice what I did. I bracketed it up with sine x, and then I closed that, and then closed the parentheses again, and squared the whole thing. The idea behind this is that sine squared x is actually equal to sine x squared, not sine x squared. No, because when we're typing this into the calculator generates these parentheses for us. And we can't do this in our technology. And this here is just totally wrong. No. And then I have to subtract the cosine x. And then multiply it. Now, I could have probably just hit sine x, but I got a little nervous. And it's actually sine alpha y equals pi times x over 2. So stuff's going to happen intermittently at intervals of pi over 2, like 1 pi over 2, 2 pi over 2, 3 pi over 2. 2 pi over 2 would just give me pi. I'm going to close it up. And I'm at the end of my... And these graphs should overlap each other. They should be the same graph when I graph it. Yeah, notice the red graph is just thrown in the blue graph. Now, I can see instantly where it's not differentiable. It's not differentiable at these cusps, okay? These little cusps. So it's 0, but it's on the open interval from 0 to 5. So I guess I'm going to second calc value and test that value of 0.9. Whoops. And 0.9, that's actually 0. So 0.9 is a non-differentiable spot. 2.4, oops, I keep saying oops. Second calc value, 2.4. Another non-differentiable spot, okay? 3.7. Not exactly not differentiable, but maybe rounded. So I'm going to go with choice A right off the start. I'm going to go with 34 as choice A. Let's see if it 0.4 is not differentiable. 0.4? No, it's differentiable. There, the slope at that point is 0. So it can't be this one. 2.4. Let's see what happens at 2.4 for choice C. 2.4. Oh, it's not differentiable there. Let's see what happens at 4.5. Oh, it is differentiable there. See, it is. At 4.5, the slope there is 0, and that's legitimate. 0.9 we already said was non-differentiable. So I'm going to type in 1.7. And no, that's got a slope. That slope's 0. So there's a distractor problem. It's going to be choice A. So for number 35, this one's a little tricky. This is an IROC equals AROC type of problem, and they don't give you a lot to go on. So I'm going to type in sine x and graph it into my calculator. And it says when the interval is 0 to b, a line tangent to the graph at x equals 1.531 is parallel to the segment connecting the endpoints. 0b. So what that means is I'm going to find the slope at x equals 1.531. And that's no difficult task. I'm just going to hit calculate 6, which is the derivative, at 1.531. Just typing in the value that they've given me. And I'm going to hit enter. And there it is. That's at 1.531. The x value is 1.531. The y value is almost 1. Almost like, at pi over 2, 1. But a little off. So it's going to have a little slightly parallel, positive slope going through it. Notice the slope at that point is 0.0397. The actual slope at that line is 0.0397858. And this is the tricky part. Okay? That's the IROC, the instantaneous rate of change. They want the endpoints of the AROC. So that's going to be sine of b minus sine of 0. Well, sine of 0 is 0. That's easy enough. Over b minus 0 equals the IROC, which is 0.0397858. And this is a little tricky. Well, sine 0 is 0. So this is going to give me sine of some number b over some number b equals 0.0397858. And there's no way for me to really algebraically solve this. It's calculator active. So I'm going to use the numeric solver on my calculator to try to attack this problem. So let me turn it on. I'm going to hit second quit. And the trick is to do math, up arrow. And there's your numeric solver. And you want a top value. And my top value is this equation. But I don't have a b button on my calculator, so I entered sine x over x. And that equals, the right side was 0.039785. Pretty close. Now, a lot of people, when they do this, they're going to hit the enter button, they believe. But no, that's the problem. You must hit the F5 up here for OK. I'm going to hit OK. And that was the last time number I entered was the 1.53. But I'm just going to hit solve. In other words, you hit this button again, and it will solve it for you. And the answer is, notice, 3.021. It's on my screen. It's on my screen. 3.021. The answer is choice D for number 30. Number 36, water is being pumped from a water pool at a rate proportional to the amount of water left in. Notice, if they say proportional, it's probably going to be a Diffie-Q question. And they give me the layout where y is the amount of water left in the pool at any time t. Initially, there were 500,000 gallons. So we're going to have a t and, I don't know, a g. So initially, that's 0. There were 500,000 gallons. And then after 10 days, there were 100,000 gallons. So it's decreasing. What is the equation for y, the amount of water remaining in the pool at any time t? Let me give us several choices. All right? So I'm going to see if I can't separate these variables. So I have dy dt equals ky. I'm going to divide both sides by y. That's going to give me 1 over y dy. And at the same time, multiply both sides by dt. That's going to give me k dt. So I separated the variables well enough. Now, the key to a differential equation is to take the antiderivative. And the antiderivative of 1 over y is ln of y equals k t, because t is my variable, kx or t, plus c. Now I'm supposed to solve this for y. Notice these are all in y equals form, y sub t form. So I have to solve this for y, so I'm going to base e it. That's going to give me e to the ln of y is just y. And remember, I can rewrite this as e to the kt times e to the c. And e to the c is just some constant. So we're going to get this new differential equation, or new equation, y equals c. I throw that out front. E to the kt. Now using this initial condition of t equals 0, and g, that's this amount over here, is 500,000. So maybe we should write this as y of t. So that's going to give me 500,000 on the left side equals c, e to the k times 0, because t equals 0. Well, k times 0 is 0, e to the 0 is 1. So this means I'm going to have c equals 500,000. And now I'm going to plug that back into this equation. And that's going to render me y equals 500,000 e to the kt. Now, I need this information to finally solve it for k. 100,000 goes over on the left equals 500,000 on the right. E, and notice, t is 10, so k times 10 can be rewritten as 10k. And all I have is one variable left to solve for, and that is going to be the k. So I divide both sides by 500,000. That's going to give me 1/5, or 0.2. Equals e to 10k. Now I ln both sides. And that's going to give me ln of 0.2 equals 10k. So the ln of e cancels out. Solving for k, I divide both sides by 10. So this is going to give me my k. So ln of 0.2 over 10. K equals negative. My k is going to equal negative 0.1609437,912, as far out as I can write it. So my equation is going to be y equals 500,000 e to the negative 1.1609 to the negative 0.1609437,912 t. And notice, none of those are there. None of them are there. So I'm going to graph that. I'm going to graph that equation. Notice I have my window set up pretty nice. I knew it was going to be a large one. My x-min is like negative 8. My x-max is 300. I don't think I needed 300, so I'll knock that down to like 200. My y-min is negative 4. I didn't need that. My y-max is 5,000. Maybe I'll knock that down to 1,000. And we'll graph it again. And there it is. That's this graph. That's this graph. Now I want to see if any of these graphs are equivalent to that. And notice, I have it already entered, so I just retyped in A. Let me highlight it so it shows up on my graph. And for this one, I recall, I don't get anything. Nothing. I don't know where that graph is. Maybe it's on the other side. So now I'm going to highlight B. No, it's not that graph. Notice it doesn't overlap it. So now I'm going to graph C. And notice, it changed the color. So it's going to be choice C. Choice C's graph, for some reason, this equation is equal to this equation.